We can multiply and divide radicals by using the basic rule of the number parts multiply the number parts. So I have that shown in red here. So the coefficients, essentially, the coefficient times coefficient, and the radical times the radical. Okay, now there has to be some compatibility with the radical parts in that the index of the radicals must also be the same. Okay, so we cannot multiply a square root with a cube root. And generally this is, and mathematically this works because this is all just multiplication. This is 6 times root 2 times 3 times root 5. Well, we can rearrange multiplication any way we want. Okay, so we just group together the coefficients and we group together the radicals. So when we multiply these radicals, since they fall under the same index, we can just multiply the factors together. Okay, so we can show this one here. So if we multiply root 2 times 3 root 5, well, we know that there is a coefficient of 3, and then the root 5 times root 2 becomes square root 10. Okay, so it's the radicals with radicals, the number parts with number parts. And that rule works for multiplication, it must work for division, since multiplication and division are essentially the same thing. Okay, they are just inverses of each other. So we do 21 divided by 3, we get the coefficient is 7, and we get square root 10 divided by square root 5, so we end up with square root 2. Okay, and then that will work. Okay, so why does this work? Essentially, we are just regrouping. We are regrouping the multiplication and division. Since multiplication and division is commutative, meaning you could rearrange it. Oh, so here, we are rearranging. So we are rearranging multiplication and division, since times and divide are commutative. Okay, and commutative means that they can be rearranged in any way. So the index of the radical is important. So only the radicals with the same index can be multiplied together. So these are compatible, whereas root 3 and root 5 are incompatible. Okay, so they're not compatible. So we kind of have to, we're going to have to leave those like that if the indexes do not match. When we're dealing with radicals, it is important to know your perfect powers. Okay, we really should know our perfect powers of 2 to at least 2 to the power 6. We should know our powers of 3 to at least 2 to the power or 3 to the power 4. We should know our powers of 4 to power 3. Okay, so maybe I'll highlight those ones where you would be expected to do these on a test without any assistance. Okay, so without any calculator. Okay, we really should know 5 to the power 3. Okay, this one we probably should know, and then our square roots to at least 12 squared. Okay, so those ones, it is, if you can know the ones that are greater, that's fine, and in fact it's much better if you do. And if you want to continue this, you can always just multiply by one more power. Okay, so in this case, if I wanted to know 4 to the power 5, I just go 256 times 4. Okay, that would give me 1024. Okay, so that knowing our powers, perfect powers, allows us to simplify our radicals. Okay, so we have here, we're multiplying some radicals here, so we have our indexes match. Okay, so that is going to be compatible radicals, so we can write this all under one index of 3. the cube root. And then we can just do powers with power, or numbers with numbers, and powers with powers. Okay, so we end up with x to the power 7. Now this can be simplified since 125, if I go to 125 is a power of 3. That's a perfect cube. So that should end up on the outside. Okay, x to the power 7. We can cube root x to the power 6 to x squared. And we're left with 1x in the radical. Okay, in fact, maybe I'll show the steps here. This is going to be 120 cube root of 125, x to the power 6, and then we have cube root of x, and then this becomes 5x squared cube root x.